What is Green's theorem? Green's theorem can be defined as a relationship between the line integral of a two-dimensional vector field over a closed path in the length and the double integral over the region it encloses. The fact that the integral of a two-dimensional conservative field over a closed path is zero. Green's theorem is used to transform a line integral into a double integral, and sometimes it is used to transform a double integral into a line integral. Let C be positively oriented, piecewise smooth, simple closed curve in a plane, and let D be the region bounded by the C. If P and Q are functions of x and y defined on an open region containing D and have continuous partial derivative where the path integral is transverse counterclockwise. So let's take a look at the equation. The line integral of C, integration of C, where P with a function of dx plus Q with a function of dy equal to double integral of D of dx dy, where integrate Q over x minus integrate P over y. So here is the equation to solve the problem regarding Green's theorem.
Suppose that we want to calculate the area of this enclosed shape that have irregular curve C and enclosed area B. Sometimes it can be very difficult to integrate over this irregular curve C. There's something called Green's theorem which can be implemented to convert integration from a curve to integration of area C and make things much easier.
So here we have a simple example of Green theorem. So evaluate line integral C x dx minus x squared y squared dy, where C is the triangle with vertices 0, 0, 0, 1, 1, 1, positive oriented. Okay, so let's get started. Let me try sketch and plot the graph. So 0, 0 here, 0, 1, and 1. Okay, so I put the region inside the D. So region D. So the direction is counterclockwise because it's positive oriented. Okay, see. So this is the line integral. Convert into the double integral. So that just take the value into the variable. So here will be P, and here will be Q. Okay, P equal to x, differential P respect to y equal to 0, Q equal to negative x squared y squared, differentiate Q over respect to x will be negative 2x y squared. Okay, so we just put into the formula here. So negative 2x y squared minus 0. Okay, so I will use dy dx because it's much easier. So I will use the term dy dx. So dy dx. So my y below the line below is, because it's 1 1, so it will be, here will be y equal to x, and above will be y equal to 1. So let's integrate the y first. So integrate 0, negative 2 over 3 x y cube x. Yes. solve it and we will get negative 2, 3, 2, 3 x plus 2, 3 x over 4 dx. Okay. So integrate. So we can simple here, but I will proceed without simpling it. So just proceed. So integrate x. So here we get negative 2 over 6 x squared plus 2 over 15 x over 5. So 0. So we can solve it. So 1, this one. So the final answer is negative 1 over 5. And that's it. This is our answer.
Okay, now let's solve another question. Evaluate integral c y cubed dx plus x cubed plus 3x y squared dy, where c is the circle x squared plus y squared equal to 9. First, let's sketch x squared plus y squared equal to 9. The radius is 3 because of the scale of 9, and x squared plus y squared is a circle with counterclockwise direction. So we can assume r is 0 to 3 and the theta is 0 to 2 pi. We can use Green theorem formula where vector field of f is equal to integral fxy dx plus gxy dy equal to double integral over r partial g with respect of x minus partial f with respect of y dA. Then we solve the problem using the formula of partial g with respect of x minus partial f with respect of y. Partial g with respect of x is 3x squared plus 3y squared, where the partial f over respect with y is 3y squared. Then we can eliminate 3y squared because of the positive and negative. And the limit of the double integral is 0 to 3 and 0 to 2 pi. So now we have 3x squared r dr d theta. Next, we replace x with the cylindrical coordinate formula where x equal to r cos theta. So now we get double integral of 3r cubed cos square theta dr d theta. So now we integrate 3r cubed cos square theta with respect of r, where r power of 4 divided by 4 cos square theta with the limit 0 to 3 d theta. Replace r with the limit 3 and 0, so we get 81 divided by 4 cos square theta d theta. Take out 81 over 4 and leave cos square theta inside. By using half angle formula, we can write cos square theta equal to 1 plus cos 2 theta over 2. So now we multiply 243 over 4 with 1 over 2 and integrate 1 plus cos 2 theta. Now we get theta plus sin 2 theta over 2 with the limit 0 to 2 theta. Now replace theta with the limit 0 and 2 pi, where sin 2 pi divided by 2 equal to 0. So the answer is 243 over 8 multiplied with 2 pi. And we get the final answer is 243 over 4 pi.